Welcome to homework.
We are given three different compounds: 4-methyl-phenol, benzoic acid, and toluene. Okay, so we would like to separate all three of them. Assume they are in mixture and they are all in solid. We're going to employ a technique called liquid-liquid extraction. So for liquid-liquid extraction, we are using two solvents, and they must be immiscible. Immiscible. So which means that they cannot be mixing with each other. They will separate in two phases. Okay, so we first dissolve our chemical species in organic solvent. For example, DCM, dichloromethane, or diethyl ether, or anything. For example, hexane also work. As long as they are considered to be organic solvent and they are immiscible in water or aqueous solution, then we can use them. And also, they have to dissolve all three chemical species at once. Okay, so we are going to first dissolve everything. Let's take DCM. So we have a solution of all three species in DCM, and then we are going to exploit the acid-base reaction. When we go back to look at our chemical species, we should be able to identify that the 4-methyl phenol and also benzoic acid, they are acidic. So that's why we can use adding base with different strength to selectively remove benzoic acid and then the 4-methyl phenol. Okay, so in order to remove the benzoic acid first, actually we can use sodium hydrogen carbonate solution, which will be a weak base. It's weak. It's weak. That is not going to react with 4-methyl phenol, but it's strong enough to react with benzoic acid. Benzoic acid. Because if we use a strong base, we will remove both benzoic acid and the phenol, which we don't want because we want to achieve separation. Okay, so assume we have a test tube or we have a container, and then we are going to mix with our organic layer, say it's on top, dichloromethane or the diethyl ether, and then we will have our aqueous solution at the bottom. The relative position actually depends on the density of the solvent you use, but right here, I just assume that the aqueous solution will be at the bottom, and then the organic layer will be on top, just for illustration purpose. Okay, after we mix both layer and they separate, actually we will have all our benzoic acid to react to be benzoate, and then they are going to migrate or they are going to dissolve or extract it to the aqueous solution, which will be our sodium hydrogen carbonate. Okay, so when we extract this layer away, we essentially remove the benzoate or benzoic acid. So we can just remove one of the component in the organic layer already. Okay, so if we want to extract back our benzoate back to benzoic acid in the aqueous solution, we can add an acid to our solution to protonate our benzoate to become benzoic acid. So that's how we convert back our benzoate to benzoic acid. Okay, so let's go back to our organic layer. We still have 4-methyl phenol and also with toluene. The next step is we are going to further mix. We are going to further mix our organic layer again with sodium hydroxide. So let's just wet to be a sodium hydroxide solution. Okay, sodium hydroxide is a strong base, and this time it's strong enough to react with 4-methyl phenol. To convert that to an anion called 4-methylphenolate, and then going to actually migrate or dissolve or extract it to the sodium hydroxide solution. Okay, so when we remove the sodium hydroxide solution away, then the remaining species in the organic layer will have toluene, and then we already achieve separation. In order to extract the toluene, the next step is pretty simple. We can just evaporate the solvent, and then we will have our toluene remain. On the other hand, we want to extract the 4-methylphenolate from our sodium hydroxide layer. Again, we just need to add acid to neutralize all the sodium hydroxide and also protonate the phenolate. And then at the end of the day, we will have our 4-methylphenolate being extracted from the rest of the mixture.